Let's talk about adding, subtracting, and multiplying functions. This lesson's kind of fun, so I hope you enjoy it. So, function operations. Common ones would be addition, subtraction, multiplication, and division. Today we're just going to talk about these three. I'll get into division and composition in another video. So notice that when I add functions, if I add a function f to a function g, it's equivalent to just adding f of x to g of x. Same thing with subtraction and multiplication. What that means for us is that manipulating these functions is actually pretty straightforward. So let's say I have f of x is equal to 2x squared plus 4x minus 6, and g of x is equal to 2x minus 2, and I'm asked to find f plus g of x. What does that mean? Well, remember the definition in that table said that f plus g of x is equal to f of x plus g of x. So if f of x is equal to 2x squared plus 4x minus 6, and g of x is equal to 2x minus 2, then by definition, all we have to do is put a plus sign in between these. So f plus g of x equals this whole statement. Okay, it was as simple as that. I just wrote the functions side by side, connected them with an addition symbol. Pretty cool, right? So the only thing I have to do from here is simplify. By simplify, I mean combining like terms. So I have 2x squared, I'll take 4x plus 2x, which is 6x, negative 6 minus 2 is negative 8. So my final answer is 2x squared plus 6x minus 8. Now let's try again. So again, I've got an f of x and a g of x, and I remember that f plus g of x is just equal to f of x plus g of x, meaning I write f of x, 4x squared minus x plus 10, so there's my f of x. I write g of x, which is 4x squared plus 7x. So I've got my f of x, I've got my g of x. I connect them with a plus sign, and then I combine like terms. So f plus g of x equals, I've got 4x squared plus 4x squared, so that's 8x squared. Negative x plus 7x is positive 6x, and plus 10. Okay? That's all there is to it. So again, for addition, we just write the functions side by side, connect them with an addition symbol, and then combine like terms. Let's practice that one more time. So f of x, in this case, equals 5x. So 5x plus g of x equals x cubed plus 7. Notice here that I don't even have any like terms to combine, so my answer is just f plus g of x equals, I'm going to rewrite it in descending order, so x cubed plus 5x plus 7. And it was as simple as that. Again, for addition, write the functions side by side and connect them with an addition symbol, and then combine like terms to get your answer. Subtraction is no different. So let's practice subtraction. Notice that, again, to subtract functions, we write the functions side by side, connect them with a subtraction symbol. So one thing will be slightly different, and I'll show you what that is. So f of x, now I need g of x, which is 2x minus 2. If I want to subtract these, I connect them with a subtraction symbol, but I have to distribute that subtraction symbol to everything in g of x. I have to distribute that subtraction symbol to everything in g of x, right? So the reason I need to do that is that the subtraction is happening to g of x as a whole, meaning I don't just subtract part of the function. So if I didn't have these parentheses, I would just be subtracting 2x, but I wouldn't be subtracting negative 2. And that's going to give me an incorrect answer. So I have to make sure to distribute that negative symbol. So what I would do is set it up like this. I'd still write my f of x, I'd still write my g of x, I'd put my g of x in parentheses, do my subtraction, and then I would just rewrite the whole thing after distributing my subtraction symbol. So I would take minus 2x, so minus 2x, and then minus negative 2 would be a plus 2. From here I just continue as normal. I combine like terms. I get 2x squared plus 2x minus 4 as my final answer. So again, notice that the only real difference here was that I had to make sure to distribute that negative symbol to everything in g of x. Let's do it again. So I start by writing f of x, and then I'm going to subtract g of x. Now I'm going to distribute that negative symbol, so I'm going to just rewrite f of x because I didn't do anything to it. I'm going to subtract 2x squared. I'm going to subtract 4x, and I'm going to subtract 9. Now I can combine like terms to get that f minus g of x is equal to x cubed minus 2x squared minus 4x, so that's minus 8x minus 11. So my final answer, f minus g of x, is equal to x cubed minus 2x squared minus 8x minus 11. The key was being sure to distribute that negative symbol to everything in g of x. Let's do that one more time. And in fact, just to do something different, let's find g minus f of x. So it won't always be f plus g, f minus g, f times g, okay? Sometimes g will be listed first, in which case we switch the order. So I would write g first, which is 2x squared plus 3x plus 9, and then I will subtract f of x. I'm going to subtract f of x, which is x to the 4th minus 4x squared minus 2. I'm going to rewrite after I distribute my negative sign. So I've got 2x squared plus 3x plus 9 minus x to the 4th minus negative 4x squared, which is a positive 4x squared, minus negative 2, which is a positive 2. Now I combine like terms, and I get that g minus f of x is equal to negative x to the 4th, see, plus 2x squared plus 4x squared, so that's 6x squared, plus 3x plus 11. Again, for subtraction, make sure to distribute that negative sign to everything that you're subtracting, every term in the function you're subtracting. All right, moving on to multiplication. Similar concept as with subtraction, by which I mean we have to multiply these together, meaning I'm not just going to, and here I'll write it out. Let's say I've got g of x times f of x. So I write out g of x, I write out times f of x. Notice if I just leave it like this, the only thing that's really getting subtracted would be negative 2 and positive 2x squared. That's all that multiplication symbol would do. So I need to make sure that I'm distributing that multiplication to every term in each function. Otherwise, I'm not truly multiplying the functions by each other. I'm just multiplying a term of the function by another term of a different function. So I wrap everything in parentheses, and then I carry out my multiplication. So I take 2x times 2x squared, which is 4x cubed. I take 2x times 4x, so it's 8x squared. 2x again, negative 12x. Keep going. So that's the first term, now my second term. So negative 2 times negative 2x squared is negative 4x squared. Do my next term, I get negative 8x. Notice that that subtraction is going with me. Finally, negative 2 times negative 6 is positive 12. So now I've done my multiplication, and I just need to simplify. So I'll combine like terms. I get 4x cubed. 8x squared minus 4x squared is 4x squared. Negative 12 minus 8 is a negative 20x. and I add 12. Okay, so doing this type of multiplication, combining like terms, these are skills we've practiced before. So really the only new thing you're learning here is just how to set up the problem, which is pretty easy, right? It's just writing the functions side by side, encapsulating them in parentheses, and knowing that we need to do our distribution. Let's practice again. All right, so we're going to multiply f of x by g of x. So I write out my f of x, put it in parentheses. I write out my g of x, put it in parentheses, and now I do my multiplication. So I'm going to take 3x squared times x, 3x cubed. 3x squared times 4, 12x squared. Keep going. Negative x times positive x is negative x squared. Negative x times 4 is negative 4x. Now I just need to take care of the 6. Negative 6 times 4, negative 6x. Negative 6 times 4, negative 24. Now I combine like terms. So I've got 3x squared. 12x squared minus x squared is 11x squared. Negative 4 minus 6 is negative 10x minus 24. So again, be careful to set up your problem correctly. For multiplication, and really you could just do this with all of them, write your functions in parentheses, then put whatever your symbol is in between them, and that way you'll never make a mistake. So this would work for addition, it works for subtraction, it works for multiplication. So write your functions side by side, each in their own set of parentheses, connect them with whatever operator you're asked to do, so in this case multiplication, and then carry it out. Let's practice multiplication one more time. So again, we write out our, in this case they ask for gfx. Now in the case of subtraction, or excuse me, in the case of multiplication, it doesn't really matter what order we write our functions in, right? Just like with addition, it doesn't matter what order we write our functions in, but since they've asked us to do g times f of x, we'll just do it that way. So again, I've written out my two functions with parentheses. I know I'm going to multiply them. So let's practice. I've got x squared times x squared. X squared times 9. Keep going. Negative 4x, make sure you hang on to that negative. Negative 4x is negative 36x. And finally, positive 1, which would just be x squared and positive 9. Now I gather like terms. So I get x to the 4th, that's taken care of. Negative 4x cubed, that's taken care of. Positive 9 and positive 1 is 10x squared. I subtract 36x and I add 9. So again, when multiplying, subtracting, or adding, write your functions in parentheses and then connect them with whatever operator you're asked to perform. Be sure, in the case of addition it doesn't really matter, right? But be sure to distribute the symbol to every term that you're asked to compute.